Hello, 30-ones. Welcome back to Logarithms. Hopefully you watched my quick little history video. It's a bit nerdy, but it definitely explains to you the laws of logarithms, which we're going to use here to help us understand a little bit more about logarithms. So, where are we going to start? Well, remember what we talked about in the last video. Really briefly, we talked about how a logarithm is going to help us solve for an unknown exponent. So how does it do that? Well, a logarithm is an inverse of an exponential. So another way to think of an inverse is to think of it as switching x and y. It's going to undo an exponential function. So let's look at this. Let's look at the graphs of these things, and then we'll look at the log function a little more. So where I want to begin is I'm just going to simply graph something we already know. Y is equal to 2 to the exponent x. Well, what do I know? I know we've got a y-intercept at 1, and I'll plot a couple points here. And I know we've got a horizontal asymptote at the x-axis. So we approach the x-axis, but we never touch it. Okay, there's a graph that I already know. Well, let's use something we already know to graph something new. We're going to graph the inverse of this. So we're going to graph this. An inverse undoes something. The other way to think of that is we're going to switch the x and the y values. Well, look at what's going to happen. Our horizontal asymptote will become a vertical asymptote. Our y-intercept will become our x-intercept. And we've got this point here, it's at 2, 4. Well, switch x and y, it's going to become 4, 2. And there is that graph. Remember back from transformations, another way to think of an inverse is to think of it as a reflection about the line y equals x. There it is. So we used our skills from transformations to draw the inverse of an exponential. Well, what I said at the beginning of the video is that an inverse of an exponential is a logarithm. But that doesn't look like a logarithm. What is he talking about? Okay, I'm going to show you how to convert to a log right now. How do we do it? Well, we need to know those laws of logarithms from the last lesson. So here we go. Let's go back and let's solve something we already know how to solve. This is an easy guy now. We say, yeah, okay, I'll make the bases the same. And if the bases are the same, therefore the exponents are equal. Yeah, you know that. Okay, well, how would I solve this in a different way? Or how would I solve this if I can't make the bases the same? Well, I'm going to use a logarithm. I'm going to take the log of both sides. And the reason I'm going to take the log of both sides is when I was a little guy, my teacher always said, what you do to one side, you do to the other. Well, the reason they said that is so we maintain equality, so we don't change the value of this. So I'm going to take the log of both sides. Now, from the history video, you hopefully remember that our coefficient and our exponent can switch spots. It's a little strange thing about logarithms, but if you watch the video, you know why that happens. There we go. Our exponent became our coefficient. Now log 2 is a number. So I'm trying to isolate for x. I'm going to divide both sides by log base 2. There it is. So I'm going to use a logarithm when I can't make the bases the same when solving for an unknown exponent. Let's try this again. Let's go, I don't know, 5 to the power x is equal to, doesn't even matter. Let's go 1/2. Okay, I definitely don't have a way to make those bases the same. So I introduce a logarithm. I take the log of both sides. Now I apply this law of logarithms. My exponent becomes my coefficient. Remember, that is on your formula sheet. And now log 5, it's just a number. So I divide both sides by log 5. Now, you can input both of these into your calculator, okay? The reason is your calculator's set up to be base 10. So these logs right here, even though we don't see it, these are base 10. We're just lazy. We don't write those as mathematicians. We're just lazy. So this is known as a common logarithm. So we don't write base 10. We would just write this. This is a common log. That's it. So we can go ahead and punch both of these into our calculator. Let's go try it. So we're going to do the first one here, log 7 divided by log 2. So here's my calculator. So if I want to put that in my calculator, I'm simply going to go log 7, close parenthesis, divided by log 2. Just like that. Okay, well, let's remember what the original question was. It was 2 to the exponent x is equal to 7. Well, let's check our work. Well, we just found x was 2.807, yada, yada, yada. So let's check our work. 2 to the exponent of the last answer. Hey, it's 7. So we did it right. We can check our work. Isn't that super cool? Okay, so what we just saw was we saw how to input these two answers that we have into our calculator. Okay, but what I want to look at now is our formula sheet for a second. If we look at our formula sheet in the logs section, what we covered in the history lesson was these three right here. Okay, those are what are known as our laws of logs, but there's actually one more law of log. Do you see this one right here? Okay, this one is known as change of base. Well, what does it do for us? Well, it allows us to simplify two logarithms into one logarithm. Okay, let's go look at the questions we just did. Well, right now we've got two logarithms, and it's not that big of a deal, right? They're easy to input into our calculator because they're base 10. I just lost part of a log there. But there's a slightly simpler way for us to write it. So here's what we're going to do. We're going to use our change of base. So we're going to write this as a single logarithm. How do we do it? Well, here's how it works. If we're looking at this formula right here, all we say is this. Notice first off, the bases are the same. They're both base A. The argument of our denominator becomes the base of the single log, and the argument of the numerator becomes the argument of the single log. So the 2 here is going to become our base, and the argument 7 is that. Okay, on the next one, we've got a 5. Argument of 5 becomes the base, and the half becomes the argument. There's a simpler way to write it. Okay, let's try another one. Let's say we had to solve, I don't know. Let's go 12 to the exponent x is equal to, I don't know, 9. All right. So unknown exponent. Can't make the bases the same. Take the log of both sides. Like that. Use our laws of logarithms. Exponent becomes coefficient. Like that. Now, divide both sides by log 12. It's a number, like that, right? And now, using change of base, we can write this as a single log, like that. Now, these are both correct answers. I really prefer the top one, right, where I can see the two logarithms. But a lot of you are going to prefer the second one, and here's why. Let's go back to our calculator. Okay, let's clear this all out. So we just came up with this answer, log 12 divided by log 9. It's that. Okay, but we said there's a simpler way to write it. Now, most of you should have this feature. Some of you might not, but if you do, what you're going to do is you're going to hit your math button. And you've been here before. A lot of you have probably used the frac to turn things into fractions. Well, I'm just going to scroll down. And what's right there? Log base. So I hit enter, and look, it gives me the ability to write a base of any logarithm I want. Log base 9 of 12. And bingo, look at that. We get the exact same answer. So even our calculator allows us to use this simplified form. That's great, isn't it? Now, don't panic if your calculator doesn't have that feature. You can always do the line above with log 12 divided by log 9. Okay, so what do we have? Now we have two ways to write our answer. But last lesson of the day that some of you might just love is there's a bit of a shortcut here. Now, the shortcut I want to explain, it's a shortcut. Shortcuts are awesome. We love them. The shortcut doesn't always work, and I'll show this to you in a minute where it doesn't. So the proper way, quote unquote, to solve any unknown exponent when we can't make the bases the same is to take the log of both sides. But what I want to do here is I want to see if there's a shortcut to go from straight from here all the way down to this simplified form. Well, let's see what we can notice. Okay, well, what I'm going to notice here is first off is that my crazy teacher, when he was doing this, wrote these two things. I went upside down dyslexic. I'm sorry, my friends. That should have been log 9 divided by 12, shouldn't have been. Oh boy. Okay. Try that again. Okay, so there. I apologize for going upside down dyslexic there. Okay, it should have been that. Okay, now that I've got that written properly, here's what I want you to notice. The base of my original exponential was 12. The base of my logarithm is 12. Oh, so when I switched from an exponential to a logarithm, my bases stayed the same. My bases stayed the same. Now what I want to notice is this, that my unknown, my exponent, and my 9, do you see they kind of switch spots? The x went where the 9 was, and the 9 went where the x was. So my bases stayed the same, and the other two parts switched. Oh, so maybe I didn't have to do these three lines in between. Let's go back and look at our other two examples. Okay, here's what we've got. Let's look at the original here. Base was 2. Base in my simplified logarithm was 2. And the x and the 7 switched spots. Oh, base was 5. Base of simplified was 5. And the 1/2 and the x switched spots. Okay, let's see if we've just made a shortcut then. What if I said solve for this? let's say 3 to the x is equal to, I don't know, 11. Well, we could do this the long way. So again, proper way, quote unquote, in my humble nerd opinion, is to take a log of both sides. The exponent becomes the coefficient. We divide both sides by log 3. This time I'll divide properly, not like the last one. Sorry about that. And now we can write this as a single logarithm using our change of base rule. Okay, there's the long way to do it. It's not that long. But now, maybe we've picked up on a shortcut. Let's do it again. Base stays the same. Log base 3. My other two parts switch. So x is now by itself, and my argument is 11. And look at that. It's the same thing. So this is a shortcut we're doing right here. We're cutting out a few steps, right? We cut out 3 lines. This line, this line, this line. But the only reason we can cut out those lines is because we did it properly the first time. So this is a shortcut that I understand why students really like. Here is your shortcut. It looks like this. It says x is equal to b to the y. If I want to convert this to a logarithm, I say my base stays the same and the other two parts switch. And there is your conversion. So it's a shortcut, my friends. Because it's a shortcut, it's not on my formula sheet. But that's one that, yeah, I might memorize. It's going to save me a lot of times. Okay, here's the only problem with shortcuts. They're super awesome, but they don't always work. Let's see when it doesn't work so you don't fall into that pitfall. Here's where it doesn't work. My little expression for the shortcut was base stays the same, the other two parts switch. So this one will work because I look at it and I say, okay, my base is 3. So this would be log base 3, the other two parts switch. There it is. Here's where it won't work in bright red. What if I gave you this? Now the little shortcut expression is base stays the same, the other two parts switch. Well, now that's getting ugly. What's my base? So on a question like this, you will have to take the log of both sides. Okay, but we'll save the solving of an equation like this for later on in the unit. Okay, friends, that was a bit of a long video. So again, what I want you to know is inverses, logs and exponentials are inverses of each other. That means they undo each other. We have a new rule called change of base. It's on my formula sheet. I need you to be really good at converting forms between exponentials and logarithms after this lesson. And if you want to use this little shortcut here, that's fine. Just be aware it's not always going to work. Okay, there it is, friends. I'll see you next time.